This lecture video is for Chem 115, General Chemistry 1 at St. Charles Community College, part of Chapter 2, looking at ions and the background on ionic compounds. So far we've talked about protons, neutrons, and electrons, and learned earlier in the chapter that if you have a neutral atom, that means the number of protons is exactly the same as the number of electrons, so the positive charges cancel out the negative charges, which makes them neutral. Well, turns out not everything is always neutral. Okay, so first let's start and remind ourselves about an atom that is neutral. So sodium-23, that tells us we have a sodium atom, which is Na, and its mass number, the protons plus neutrons, the number of things in the nucleus, is a total of 23. So if we want to break this down by protons, neutrons, and electrons, I want to know how many protons and how many neutrons and how many electrons are in this atom. Well, for protons, we could look up with our periodic table for the symbol Na, and find the whole number in that box. That whole number is 11. So sodium-23 has 11 protons. Actually, every atom of sodium has 11 protons because Na and 11 always go together. Okay, well, if it's neutral, we know that if it has 11 positively charged protons, it would also have to have 11 negatively charged electrons, so that way the pluses and the minuses cancel each other out. If I wanted to figure out the number of neutrons, that requires a tiny bit of math, which is subtraction. The total of protons and neutrons is 23. If we've already decided that the protons are 11, 23 minus 11 gives us 12. Remember, 23 is the total, protons plus neutrons. So here's our breakdown of protons, electrons, and neutrons. So I got the 11 protons from the periodic table. I know it has 11 electrons because I'm telling you that it's a neutral, and that means the positives and the negatives have to be equal so they cancel each other out. And I got 12 neutrons by taking 23, the mass number, which means protons plus neutrons, minus the 11 protons. 23 minus 11 is 12, so there we go. So again, if it's neutral, it's the 11 positives and the 11 negatives canceling each other out that makes the atom neutral. What happens if the atom is not neutral? Well, if the atom is not neutral, we have an ion. But if it's not neutral, that means the number of protons and electrons have to be different. So we have to decide which one's going to change. If an atom is positive, does that mean it has more protons? If an atom is negative, that means it has more electrons. So yeah, sure, if it's positive, that means it has more protons. And if it's negative, it has more electrons. But what is changing? Well, the number of protons cannot change in an atom. If you change the number of protons, you've changed the element. We can't just do that unless we're doing nuclear chemistry, and we're not. You can't mess with the nucleus of an atom. So if you take a sodium atom that was neutral, and all of a sudden it has a positive charge, that does not mean it gained a proton. All that can change are the number of electrons. The electrons are not in the nucleus. The nucleus itself cannot change during a chemical reaction, but the electrons sure can. So an ion is when we have a charged atom or molecule where the number of electrons have been added or removed. So it has a charge because it's either lost or gained electrons. So sodium. If sodium has a positive 1 charge, so it would look like Na with a plus sign next to it, let's figure out how many protons and electrons it will have. I've dropped out neutrons here. Neutrons don't have a charge, remember, so that's not changing. So we're kind of ignoring the neutrons when we're talking about ions, not because they don't matter, but kind of because they don't matter, because they don't impact the charge. Okay, so sodium plus 1. Protons, well, Na is still the same symbol, so it still has to have 11 protons. For electrons, well, when we take the protons and the electrons, we need to have 1 more proton than we do electrons, because it's got a positive charge, right? So there's 1 more positive than there are negatives. So if it has 11 protons, it's going to have 10 electrons. 11 positive charges, 10 negative charges. We add those together, we would get a positive 1 charge. So what happened was 1 electron was removed. It started out when it was neutral, 11 and 11. And what happened was the protons do not change, so instead we lost an electron. So in real life, what this atom would look like when this happens, the circle on the left is showing us the neutral atom, although the nucleus is way too big in this picture, but whatever. And then the circle on the right would be what the sodium with the plus charge looks like. which means it's lost an electron, which seems like a giant change in size, especially since electrons are tiny. But just remember that opposites attract, right? So in this case, the positively charged nucleus is stronger than the negatively charged electrons. So those electrons get pulled towards the positive nucleus, just opposites attract, so the electrons get pulled towards the center. So let's try this again. What happens if I have a chlorine atom with a -1 charge? So I would write that with Cl is the symbol for chlorine with a negative sign. So I want to know the protons and electrons. So I need to get my periodic table, find Cl, and look at the number of protons. Well, according to the periodic table, there's a 17 in the box with the Cl. So it has 17 protons because it's Cl. Okay. Well, if it's got a -1 charge, that means it has to have one more electron than it would proton. So if it has 17 protons, it's going to have 18 electrons. More negatives than positives in this case. So what that atom would look like, it actually gets bigger when it gains electrons. I think that makes sense, right? We add something to it so it gets bigger. So the number of protons in a neutral atom will never change when they turn into an ion. Protons don't change. They're in the nucleus. The nucleus doesn't change when we do a chemical reaction. Changing the number of protons will change the type of element. Chlorine will become argon. Whatever, we'll change the element to a different thing. That is not an ion. An ion, when we change the number of electrons. The nucleus is never changed by chemical processes. Okay, so important things. Only the number of electrons will increase or decrease when we have an ion. So I put a yellow box around this because these are kind of important things, my friends. So when we have an ion, that means the number of electrons only change. Okay, we don't change the number of protons. We don't change the symbol. All that changes is the number of electrons. We can figure out the number of protons by always looking at the periodic table and finding that element on the periodic table. The whole number in that box will tell you the number of protons. So let's practice. Here's another table. I like to ask these types of questions in tables. So nitrogen is a -3. And when we write the ionic charge, we do put the number and then the sign. So I said it wrong. I said -3, but it should be 3 minus. So we put 3 and then the minus. So nitrogen with a 3 minus. The number of protons. Let's look at the periodic table. Find N, 7. Number of electrons. Well, based on the charge, it should have 3 more negatives than it does positives. Electrons are the negatives, so we have to have 3 more, so 10. Calcium, 2 plus. We look at the periodic table. On the periodic table for Ca is 20. Since it has a 2 plus charge, that means it has 2 more positive pieces than it does negative pieces. We have to remove 2 negative pieces. If we have 20 positive pieces, we have to have 2 less, so 18 negative electrons. So Al3 plus, so aluminum with a 3 plus charge. So aluminum, we look at the periodic table, 13. 3 plus, so it has 3 more positives than it does negatives. So remember the electrons are the negatives, so we need to have 3 more protons than we do electrons, so 10 electrons. Iodine, negative. So the negative, I know there's no number there, but we don't have to write 1. So we don't have to write 1 minus. So I minus means it's a -1 charge. We look up iodine on the periodic table. 53 is the number of protons. It has a -1 charge, so it has to have 1 more negative electron than it does protons, so 54. Silver, Ag, plus. So again, that means +1. So silver on the periodic table has 47 protons. It has to have 1 more proton than it does electron, so 46 electrons. You have to remember when we're doing this, protons are positive, electrons are negative. That's a really important thing to remember when you're working through this. Okay, so hopefully that went well. If not, like I said, you can talk to me later. So vocab-wise, anything with a charge is an ion. But we have a term for all the things that are positively charged are called cations. Now this picture is really creepy. I'm just warning you up front. It was not supposed to be this creepy. But the way I remember cations, hey, there's a cat. Hey, it has plus sign eyeballs. Oh, cations are positively charged. It's not a cation, by the way. That's not how we say this. It's a cation is how we say this term. So all positively things are cations. So +1, so like a plus, a 2 plus, a 3 plus, a 4 plus, a 7 plus, whatever. If it's got a plus, it's a cation. So negatively charged things are called anions. This picture is not as great. It's an ant with a negatively charged things. I'll draw these on the board. I'm a horrible artist, so they're probably better on here, but the cat just really does kind of creep me out. All right, so cations positively charged things, anions negatively charged things. So it could be negative, or 2 negative, or 3 negative, or 4 negative. Anions are just, there's a negative sign there. And then there are neutral atoms, which are neither cations or anions or ions at all. So neutral is another option, but we're not talking about an ion then. So all we've looked at so far are called monatomic ions. It's just one atom, right? Al, 3 plus, N, 3 minus, Ca, 2 plus. But we can also have polyatomic ions, which means there's multiple atoms grouped together, and all of them together have a charge. Again, that's the ion term. So some examples of this are ammonium ion and nitrate ion. So ammonium ion, 1 nitrogen, 4 hydrogens, all together, all 5 atoms, the 1 nitrogen and the 4 hydrogens together have a +1 charge. Nitrate, 1 nitrogen and 3 oxygens, all together, those 4 atoms, the 1 nitrogen and the 3 oxygens have a -1 charge. A charge does not just apply to the last atom, it's the whole group. Okay. So if we want to predict what charge an atom is going to have when it becomes an ion, we can do that. And the way we can do that is actually going to come from the idea of the noble gases, which are group 18, the very right-hand column on the periodic table. Those buddies are noble gases. Noble gases are unreactive and very stable, which means they don't form compounds, they don't form molecules. They're just single atoms by themselves because their arrangement of electrons, so their number of electrons, is very, very stable. So all the other atoms on the periodic table are less stable than the noble gases. If they can get to that magic number of electrons, like one of the noble gases, they become more stable. Still not as stable as the noble gases, but much more stable. So the way we can predict what their charge will become, other elements are going to lose or gain electrons. So that way they have the same number of electrons as the noble gas that is closest to them. They don't change their protons though, so other elements do not become noble gases. They just change their electrons, so they are the same number of electrons as a noble gas. Their protons are still whatever they are, okay? But the reason why they do this is having the same number of electrons as a noble gas will give it some of the stability that the noble gases themselves have. So we can look at the charges based on the group that the element lives in. So in the next image is the picture coming from the textbook, and I'm going to, in class, make sure that you write this on the top of your periodic table. So group 1, which is also called 1A, everything in group 1, when it becomes an ion, will have a +1 charge. So I want you to write top of your periodic table above group 1, like plus. So everything in group 1, when it's an ion, it will have a +1 charge. It can also be neutral, which means it has a 0 charge. But if it is an ion, it is a +1. Group 2, everything in group 2, when it's an ion, this is beautiful. It's going to be a 2+. Okay, all of group 2 is a 2+. And then we're going to come over here to group 13. Everything in group 13, when it becomes an ion, is going to become a 3+. Again, they can be neutral or they can be 3+. That's the only choice. Group 14, we're not going to write anything above that because there's not one charge that they all become. Group 15, everything in group 15 is going to be a 3- when it's an ion. Everything in group 16 is going to be a 2- when it's an ion. Everything in group 17 is going to be a -1 when it's an ion. And everything in group 18 is a noble gas, which means it doesn't form an ion and it is completely neutral. So the way, if you look at this, so oxygen as a neutral atom has 8 electrons. Its closest noble gas, neon, has 10 electrons. So if oxygen has 8 electrons and neon has 10 electrons, oxygen would like to get to 10 electrons as well to become as stable as its noble gas. So if it started with 8, what it does is it gains 2 more electrons, which is how it ends up with a -2 charge. Okay. You're going to want to memorize this. Group 1 + 1, group 2 + 2, group 13 + 3, group 15 - 3, group 16 - 2, group 17 - 1. It's going to be expected that you can predict the charges of any element in one of those 6 groups. Now, there's a lot of groups we didn't write charges over, right? All these buddies here in the middle, They're called transition metals. They're called transition metals because they have more than one charge. So we can't just memorize it. It's different every time. Group 14, this buddy right here, same way. So we're not memorizing anything because we can't. It's different. Noble gases, you can just say are zero. They don't have a charge. They are not ions. So if we can predict the charge on an ion, if I say, well, I'm going to take two ions, one that's a cation, positive charge, and one that's a negative ion, an anion, negative charge, they will come together and form what is called an ionic compound. They are ions that come together to be neutral to form a compound. Compounds are always neutral. So if it has a charge, it's an ion. If it's a compound, it's neutral. So an ionic compound, two different ions that came together so their charges canceled out to make them neutral. So for example, the element sodium and the element chlorine, when they react, they are going to form a compound made up of sodium and chlorine. Well, sodium becomes sodium ion with a +1 charge, and chlorine becomes Cl with a -1 charge. Go back and look at the periodic table and you'll see why. Sodium is in group 1, which is a +1. Chlorine is a group 17, which is a -1. So this is what they become. Well, when they form a compound, they're going to come together in whatever increments, however many number of each of them it takes to get their charge to 0. Well, if sodium's a +1 and chlorine's a -1, +1 and -1 add together to equal 0. So the ionic compound is going to be NaCl, 1 sodium, 1 chlorine. Notice when I write them together as a compound, their charges disappeared. What happened was their charges canceled out. So we don't have to write Na plus Cl minus. We just write NaCl all together is neutral. Ionic compounds always must be neutral, which means the positive and the negative charges will always cancel out. So let's practice this. I got another table. I love my tables. So what I've got for each row, I've given us one cation and one anion, and we're going to predict the compound. Now, for the cations and anions that we can predict their charge based on where they live on the periodic table, we're going to do that. So aluminum, Al, look on the periodic table. It's in group 13. Group 13, we said just a minute ago, will always have a 3+ charge when it's an ion. So let's look at nitrogen. Let's figure out its charge. So it's in group 15, which I said earlier was always a 3- charge. So if I take an aluminum with a 3+ and a nitrogen with a 3-, and I want to put them together to make a neutral, overall 0 compound, well, doesn't +3 and -3, don't they add up together to equal 0? So all it takes is one aluminum, one nitrogen, so their compound would be AlN. We always write the positively charged thing first and the negatively charged thing second. So it would not be NaL. NaL would be incorrect. It goes cation, then anion. Second row. Well, for both of these, I gave you the charge because I would expect iron, Fe, you don't know what its charge is. So I'm telling you it's 3+. Carbonate, 2-, it's a polyatomic ion. It's on the list of polyatomic ions that you have to memorize. So when we put these together, I need those charges to cancel. But if you look at it, 3+ and 2- don't automatically cancel out to 0. So we're going to have to put them together in a way so that way all of their charges add together to equal 0. Well, the issue is I need to find basically a lowest common denominator here. What number can +3, or at least can 3 and 2 both equal? And the smallest number there is 6. So in order to get 6 positives and 6 negatives, which is the first time I can get +3 and -2 to both equal 6. It's going to take 2 irons to get to +6, a 3 and another 3. And it's going to take 3 carbonates to get to -6. So it's going to take 2 irons and 3 carbonates. So we would show that like this. Fe with a subscript 2 showing 2 irons. And then CO3, which is carbonate, with parentheses around it showing the 2. The reason why I'm going to do those parentheses, because if we wrote it, this is going to be beautiful, just be prepared. F, oh yeah, that's good. E, even better. 2, C, O, 3, and then to show that there are 2 of them, and if I just did this, doesn't that say 2 iron? Well, what it's supposed to say is 2 irons, 1 carbon, and it looks like 32 oxygens, which is not the same thing as this, which is trying to say 2 irons. Oh, wait a second. I can't math. This is supposed to be a 3, and this is supposed to be a 3. Typo I never realized before. So it would be 3 carbonates to get to the -2. So either way, parentheses are important for those polyatomic ions. Let's try another one with a polyatomic ion and see how this goes. So the third row, zinc, Zn, I'm telling you is a 2+ charge. NO3 is the nitrate polyatomic ion as a -1 charge. So when I go to put them together, 2+ and -1 don't automatically cancel. It's going to take another negative nitrate because I have 2 positives and 1 negative right now. What I need is another negative. So it's going to take 1 zinc and 2 nitrates. All right, next row, we're going to have to figure out their charges. So sodium, find sodium on the periodic table. It should have a +1 charge. Find sulfur on the periodic table. It should have a -2 charge. So when I go to put these two ions together, it's not going to be 1 sodium and 1 sulfur because those charges don't cancel. It's going to be 2 sodiums and 1 sulfur. A +1 to cancel out with a -2. Okay, one more. Barium, Ba. Look at it on the periodic table. It's going to be a 2+. Bromine, a Br. Look at it on the periodic table. It's going to be a -1. So one of each of them is not going to work. The charges aren't going to cancel. It's going to take 1 barium, 1 bromine, and then a second bromine. So Ba, Br, 2. Good news is we're going to get a lot of practice with this when we get to our naming. So if this is causing headaches, we'll practice. So ionic compounds, just so you know what they look like, if you've seen table salt, which I'm pretty sure you have, table salt is sodium chloride, an ionic compound. So everything about table salt pretty much defines what an ionic compound looks and acts like. It's little tiny crystals. It dissolves in water, and it's made up of alternating sodium chlorine, like positive, negative, positive, negative, positive, negative. So that's just a close-up view there on the right with part C of sodium chloride crystals. So we've looked at ionic compounds. That's awesome. Ionic compounds are typically made up of at least one element that's a metal and one element that's a nonmetal, but they are always cations and anions, positive charge, negative charge. Another type of compound are called molecular compounds. Molecular compounds are typically 2 atoms that are both non-metals. They're not ions. They're not cation, not anion. So we're just going to practice looking at compounds and deciding if we think that they are ionic compounds or molecular compounds. The easiest way to do this is to try to look at if they're metals and nonmetals or nonmetals and nonmetals. A metal-nonmetal combo, that's ionic. A non-metal-nonmetal combo, that's molecular. So MgCl2, well, look at Mg, it's a metal. Look at Cl, it's a nonmetal. So it's going to make this ionic. CBr4, well, let's look at C, it's a nonmetal. Br is a nonmetal, that makes it molecular. PbF2, Pb is lead, that is a metal. F is fluorine, that's a nonmetal, so ionic. Fe is iron, S is sulfur. Iron is a metal, sulfur is a nonmetal, so ionic. P4O6, P is phosphorus, that's a nonmetal. Oxygen is a nonmetal. O is oxygen, it's a nonmetal, so that's molecular.